Step two of making these roller coaster models was to describe the energy using energy bar charts. To do this, I would recommend that you look at the Energy Skate Park assignment, where I asked you to open up this formative, which gives you access to this simulator about this energy skate park. In this assignment, we looked at the bar graphs and the speed of a skateboarder going back and forth. By answering the questions in this energy skate park assignment, we were able to investigate what do these bars mean, kinetic, potential, thermal, and total energy of a person or object moving back and forth, up and down on an energy skate park. And we applied these same graphs to our own roller coasters. In the assignment Improved Models Roller Coaster, I gave you some additional instructions to take the first drawing that we did in the first step and to improve on them by adding these energy bar charts to different locations of the roller coaster. So here's what my model is looking like so far. In the first step, I have drawn the shape of the roller coaster. I've designed that, and I'm using this arrow to show where the coaster is at the first position. So at the top of this first hill, I'm going to draw my first bar charts. On this graph, my y-axis is going to be how much energy there is, and my x-axis down here, I'm going to put the different types of energy. I'm going to start with the total amount of energy that is in this roller coaster. And in this first location, I'm going to be looking at how much potential, how much kinetic, and how much thermal energy there is. And I'm just going to estimate how big to draw the bars. So starting with potential energy, I know that this roller coaster is pretty high up off the ground. And so I'm going to give it a lot of potential energy, because when we've talked about potential energy, we've talked about how it comes from how high up off the ground you are and how much you might fall, how much energy there might be once you fall back down to the ground. So I'm going to give it a lot of potential energy here. And that's all you have to do for the first location. You're going to do this for 3 more locations, and I'm going to show you just one more to give you another example. So let's zoom in right over here on the loop-de-loop, right when the roller coaster has come down and is starting to go back up through this loop-de-loop. So again, our y-axis is going to be how much energy there is. We're going to measure the total amount of energy, how much potential energy there is, how much kinetic energy, and how much thermal energy there is. The first rule is that the total amount of energy from this first location to the second location has to stay the same. So I'm going to draw my total energy bar first this time, and I'm going to make it the same height, just estimating, the same amount of energy as there was in the first location. Now I'm going to turn to potential energy. The roller coaster is not nearly as high as it was back when it was over here, so my potential energy bar is going to be a lot smaller. The kinetic energy bar, now this roller coaster is moving fairly quickly going up this hill. I'm going to make my kinetic energy bar quite a bit bigger. And then the last one is thermal. Thermal energy is coming from friction. And how much friction has been built up? Well, the amount of friction, the amount of thermal energy, is what would be left over of the total energy that's not kinetic or potential. So if I imagined that this blue bar and this green bar were stacked on top of each other, they would come to about this high. And that means what's left over is just this tiny little bit of total energy left over. So I'm going to add that tiny little bit of energy left over there. So if I took thermal, kinetic, and potential and I added them up, they should be the same height as the total energy here. And I can sort of show you that. So if I did the potential energy would be, all of this would be potential energy here. And then if I took this kinetic and I stacked it over here, then this kinetic would be up to about there. All of this energy would be the kinetic energy. And then this thermal bar would be this last one, and all of this would be thermal. They sort of stack up on top of each other, just like that. Now, I'm going to let you do your own for 2 more locations on this roller coaster ride. It could be once the roller coaster loops around over here. It could be as it's going around this banked curve, or it could be on one of these hills towards the end. But again, you do the same thing with where you make your axes, label it energy, and then measure the total thermal, kinetic, and potential energies, just like we did here. Remember that potential is always based on how high off the ground it is. So if the roller coaster is right on the ground, like over here, then the potential is going to be 0. If it's higher up, like on a hill, the potential energy is going to be higher. Kinetic energy is related to how fast the roller coaster is going. So the faster the roller coaster is going, the more kinetic it has. And the thermal energy is always going to be increasing. The thermal energy never goes down because we're just generating more and more heat. The farther we go, the more thermal energy. So in this final location that you show, the thermal energy bar will probably be the biggest, aside from the total energy, which always stays the same size.